Okay, today I will show you how to integrate by part for this question. Okay. The question state that integrate x the power of n sin ax dx y n less than or equal to 2. Okay. Next, uh, we let the n equal to 2. Okay. We integrate x the power of 2 sin ax dx. So, how we integrate this question? We must use this formula to integrate this question. Okay, next we must know how to determine the u and dv. Okay, how we determine the u and dv? We use this at lipad. Okay, from the question we know that they have two functions that x squared equal to polynomial function y sin ax dx equal to trigonometric function. We let u equal to x squared and dv equal to sin ax dx. Okay. So we differentiate x squared. We got du equal to 2x dx. While we uh, integrate integrate sin ax dx, we got v equal to 1 over a cos ax. So we put this into the formula. So integrate x squared sin ax dx equal to uv x squared multiply negative 1 over a cos ax minus integrate v du v du negative 1 over a cos ax 2x dx. So we simplify it to negative x squared over a cos ax plus 2 over a integrate x cos ax dx. So this integrate have two functions, so we must use the integrate function, integrate by part again. So we must determine the u and the dv first from integrate x cos ax dx. Okay, we let u equal to x y to cos ax dx. So we differentiate x, we got du equal to 1 dx. Y we integrate cos ax dx, we got v equal to 1 over a sin ax. So we use the formula integrate u dv equal to uv minus integrate v du. Okay, we get integrate x cos ax dx equal to x equal to uv x multiply 1 over a sin ax minus integrate v du 1 over a sin ax dx. So we simplify it, we got x over a sin ax plus 1 over a integrate sin ax dx. Next, we must integrate sin ax dx. We got the negative 1 over a cos ax. So from this, we simplify it to x over a sin ax minus 1 over x squared cos ax. So the final answer is the final answer for the integrate x squared sin ax dx equal to negative x squared over a cos ax plus 2 over a multiply x over a sin x minus 1 over x squared cos x ax. So we we multiply it, we got negative x squared over a cos ax plus 2x over x squared sin ax minus 2 over a the power of 3 cos ax plus c. Why we plus c? Because this is the indefinite integral. Okay, so that's all how we answer this question using the integrate by part.
Assalamualaikum and hi, my name is Muhammad Azam and today I will show you how to solve this problem, which is integrate x power of n times cos of ax dx, which is n less than and equal to 2. For this question, we can use product rule to solve this question. This is the product rule formula, which is integrate f of x times g of x dx equal to f of x times g of x minus integrate f prime of x g of x dx. For this formula, we can use the alternative form, which is u equal to fx, v equal to g of x, and du equal to f prime of x dx, and dv equal to g prime of x dx equal to g of x dx. So we can get the alternative form equal to integrate u dv equal to uv minus integrate v du. Okay, for this question, f of x equal to u equal to x power of n equal to x power of 2, which is n is equal to 2. For f prime of x dx equal to du equal to 2x, g of x equal to v equal to sine ax over a, g prime of x dx equal to dv equal to cos of ax. For the step 1, we can use this formula, which is integrate u dv equal to uv minus integrate v du. First, we can get the information from this one and substitute into this formula, and we can get integrate x2 times cos ax dx equal to x2 sine ax over a minus integrate 2x sine ax over a dx. For the step 2, we need to solve this first. So for solve this first, we can use the formula. We can use the product rule formula also to integrate the equation. To simplify the equation, we can put 2 over a outside from the equation. After that, we can get the info from this, which is u equal to x, du equal to 1, v equal to negative cos ax over a, dv equal to sine ax. After we got the information, we can substitute the information into the formula, and we can get integrate x sine ax dx equal to negative cos ax over a minus integrate negative cos ax over a dx. After that, we need to solve this one. So for the step 3, by using chain rule, we can solve this one. Let s equal to ax dx equal to a. So dx equal to 1 over a ds. After we get the information for this, we can solve this question, which is integrate negative cos ax over a dx equal to negative 1 over a power of 2 integrate cos of u du. After integrate cos u du, we got sine u. After that, we got a negative sine u over a square, and substitute the value of u, which is ax, and we got negative sine ax over a square. For the step 4, after we got the value for integrate negative cos ax over a dx, we can solve integrate x sine ax dx. Write back the equation, which is negative x cos ax over a minus integrate negative cos ax over a dx. We got negative x cos ax over a minus negative sine ax over a square, and the answer is sine ax over a square minus x cos ax a. After that, after we got the value for integrate x sine ax dx, we can solve this one, which is 2 over a integrate x sine ax dx equal to over a. Substitute the value of integrate x sine ax dx. We got sine ax over x square minus x cos ax over a, and we got 2 sine ax over a power of 3 minus 2x cos ax over a power of 2. Further step 6. After we got the value of integrate 2x sine ax over a dx, we can solve the main question, which is integrate x squared cos ax dx equal to x squared sine ax over a minus integrate 2x sine ax over a dx. Right back, x squared sine ax over a minus 2 over a integrate x sine ax dx. Substitute the value, and we got x squared sine ax over a minus 2 sine ax over a power of 3 plus 2x cos ax over a square plus c. After that, we need to for this one, we need to get a same denominator, which is we need to multiply this one with a power of 2, and this one we need to multiply by a power by a. So we got a square x squared sine ax over a power of 3 minus 2 sine ax over a power of 3 plus 2 ax cos ax over a power of 3 plus c. And the final answer is a square x square minus 2 sine of ax plus 2 ax cos ax over a power of 3 plus c. Thank you. That's all from me, and thank you for watching.
Okay, Assalamualaikum warahmatullahi wabarakatuh. Today I'm going to explain how to evaluate integrals using integration by parts. So let's take one example of integrals. Integrals e to the ax sin dx. So firstly, we have to apply integration by parts like this. Let u equals to e to the ax and dv equals to sin dx. So the derivative of u equals to a e to the ax. And to find v, we must integrate sin dx, which is equals to 1 over b negative cos bx. Next, by using the formula for integration by parts. Okay, this is the formula for integration by parts. Integral u dv equals uv minus integral v du. So from above, we substitute this equation into the formula for integration by part, and we will get this. Integrate e to the ax sin dx equals to e to the ax 1 over b negative cos bx minus integral 1 over b negative cos bx multiply a e to the ax dx, and this equals to negative 1 over b e to the ax cos bx minus integral negative 1 over b a e to the x cos bx dx. This is just we put this constant and this negative up front, and also this constant we put it up front, so we can integrate e to the x sin dx equals to negative 1 over b e to the x cos bx plus because negative with negative, so plus a over b we get from this 1 over b multiplied with a, and we put out front and let this be like this. Integral e ax cos bx dx. So from this equation we know that there is another integral that we must do second integration by parts, like above. So we must apply integration by part. Let u equals to e to the ax and dv equals to cos bx. Yes. So derivative of u, we know that derivative of u equals to a e to the ax, and v equals to 1 over b sin dx. We must integrate cos bx first. Okay, similarly again we must substitute in the formula for integration by parts, and we use this equation into and substitute in the formula, and we will get this integrate in e to the ax cos bx dx equals to e to the ax 1 over b sin bx minus integral 1 over b sin bx multiply a e to the ax. Then so equals to 1 over b e to the x sin dx minus integrate 1 over b a to the a e to the x sin dx. This is just we put this constant up front of e to the s, and same here we put this constant up front. Okay, next substitute integrate e to the x cos bx into the formula from this. Integrate e to the x sin bx dx equals to 1 over b e to the x cos bx plus a over b negative e to the x cos bx dx. So we substitute this with this equation. So we get integrate e to the x sin bx dx equals to 1 over b e to the x cos bx plus a over b in bracket 1 over b e to the x sin bx minus integrate 1 over b a e to the x sin bx. So we just expand both of this expression. We get from this a over b multiplied with 1 over b e to the x sin bx, we get a over b squared e to the ax sin bx, and minus this a over b multiplied with integrate 1 over b a e to the ax sin bx. So we get a squared over b squared integrate e to the x sin bx dx. Okay, Okay, next, from the from the from the right hand side, we can move this expression in front because it is similar with the with the example. So we can combine and factorize them like factorize a to the a squared over b squared plus 1 integrate e to the x sin dx dx equals to negative 1 over b e to the x cos bx plus a over b squared e to the x sin dx. So from this we will get this a squared plus b squared over b squared integrate e to the x sin dx dx equals to 1 over b e to the ax cos bx plus a over b squared e to the ax sin dx. So we move so integrate e to the x sin dx dx equals to b squared over a squared plus b squared. This is just change it in bracket 1 negative 1 over b e to the x cos bx plus a over b squared e to the x sin dx. So we expand both of them in this bracket, and we will get integrate e to the x sin dx dx equals to negative b e ax cos bx over a squared plus b squared plus in bracket a e to the x sin dx over a squared plus b squared and c. Okay, this is the answer for integrate e to the x sin dx dx. Okay, that's all about integration by parts from me. Thank you.
Okay, hello guys. Today I want to teach you about the integration by part. Okay, in the integration by part, you have to know about the general form of the integration by part. This is general form for the integration by part. Okay, let's go to question. Okay, the question is integrate exponential the power of ax cos bx dx. Okay, firstly we have to separate the exponential function and trigonometric function. Okay, when we separate, we get like this. Alright, we get u equal to exponential power of ax and dv is equal to cos bx dx. And when we differentiate u equal to exponential power of ax, we get du equal to a times exponential power of ax dx. When we integrate dv equal to cos bx dx, we use u substitution. U is equal to bx, du over dx equal to b, dx is equal 1 over b times du. And when we integrate cos u du, we got sin u, and we multiply it and we get v equal to 1 over b sin bx. Okay. Okay, after we get all the answer for this equation, we take it into the general form and we get like this. Exponential power of ax times with 1 over b sin bx minus integrate 1 over b sin bx a times exponential power of ax dx. And for this question, we have to simplify it, and we get 1 over b exponential power of ax sine bx minus a over b sine bx exponential power of ax dx. We take a in front of the equation, and we get a over b here. Okay, after this, we also simplify it again, and over b exponential power of ax sine bx minus a over b integrate sine bx exponential power of ax dx. We took a over b in front of the equation, and after this we also have to integrate this equation by integration by part, and we let u is equal to exponential power of ax and dv is equal to sine bx dx. When we differentiate u equal to exponential power of ax, we get du equal to a times exponential power of ax dx. And dv, we using the u substitution, we let u is equal to bx, and du over dx equal to b, and dx 1 over v du. And we integrate sine u du equal to negative cos u, and we time multiply together, and we get v is equal to negative 1 over v cos bx. Okay, after we get all the answer, and we take it to the general form of the IBP for this equation, and we'll get like this. Alright. Okay, for this equation, also same like before, you have to simplify it. We get for this equation exponential power of ax times with negative 1 over v cos bx minus integrate negative 1 over v cos bx times a times exponential power of ax dx. Alright, we simplify it, and we get negative 1 over b exponential power of ax cos bx minus integrate negative a over b cos bx times with exponential power of ax dx. Okay, we simplify again, and we open the bracket also. Okay, we get negative 1 over b exponential power of ax cos bx plus a over b integrate exponential power of ax cos bx dx. Okay, after we get all the answer in the general form of the IBP, and we have to combine all the equation for the first, second, and third, and we'll get like this. Alright. Okay, we get integration exponential power of ax cos bx dx equal to 1 over b exponential power of ax sin bx minus a over b open bracket minus 1 over b exponential power of ax cos bx plus a over b integrate exponential power of ax cos bx dx close bracket. Alright, from this equation, we have to simplify it, and we open the bracket first, negative 1 a over b and negative 1 over b exponential power of ax cos bx, we got positive, and we also open bracket the second, and get negative a square over b square integrate exponential power of ax cos bx dx. Okay, we took all the integration to the left hand side and the equation to the right hand side, and we get this. Okay, we simplify integration equation, and we have to take it of 1, and also like this. Okay, we get 1 plus a square over b square time with integrate exponential power of ax cos bx dx equal to 1 over b exponential power of ax sin bx plus a over b square exponential the power of ax cos bx. Okay, we also simplify again. We same the denominator and numerator, and also this we take same the denominator, and alright, we can time b square here, and we can cancel out all the left hand side and right hand side equation, and we get like this. B square plus a square time with integrate exponential power of ax cos bx dx equal to b times exponential power of ax sin bx plus a times exponential power of ax cos bx. Okay, for this we get like this. we took b square plus a square to the right hand side, and we get integrate exponential power of x cos bx dx equal to this. We factorize the exponential function because left and right. All right, factorize it, and exponential power of x sin bx plus cos bx, close bracket, open bracket, close bracket. Okay, divide by b square plus a square, and do not forget to plus c. All right, okay, this for the last answer. And okay, that's all.